we're getting closer to full release of ColourSpace, it's worth having a look at some of the fundamental capabilities, features, options built into the system, get an idea of where we are in our development cycle, as well as where we're going as we add more and more features into the system. So when we first open up ColourSpace, we get a floating window that gives us our major options. So Tools menu just replicates these buttons, obviously help to give you licensing information on that. First up is the ColourSpace Manager, which is just a library. It holds all the existing colour spaces built into the system, as well as any profiles that have been generated within ColourSpace or indeed loaded in from Lightspace. You can do the usual modifications of a colour space. You can take existing profiles, export them, delete, rename and so on. More interestingly is this ability to extract a colour space from them. For example, here we have Chroma colour space, which is of a display that is in its uncalibrated state, and above it you can see the same name but with the word matrix after it. I'll just delete that and we will redo it. And what this is using the modification capability to actually extract a colour space from the profile. So if I just call this matrix, there we go, and extract colour space, it has now taken that profile and extracted from it the RGB gamut and the gamma from the actual colour space itself. That means that we can now look at that profile to assess just the volumetric information of it, rather than trying to compare it to a specific colour space. That really helps understand the underlying capabilities of the display. We'll come back to that. Next up is profiling, and profiling is obviously where we do our measurement work within ColourSpace. We can resize all of these windows to get into more information. In fact, let's just make that full screen. And all the graphs can be moved, manipulated, zoomed, scrolled, all the usual. And then we have over here our various settings for ColourSpace, probe options, so select whichever probe we're working with, in this case the I1D3, connect to it, hardware configuration not yet populated, graph options to see what information we want to see in the graphs, and then the manual measurement tools themselves, as well as characterization. So if we go back and look at the settings, just reduce that down a little bit so we've got some space to get a patch window up. There we go. So we've got the usual settings options to configure the colour space target and the gamma target. At the moment they're interlinked, they will be separated. Here we have the luminance target, in this case 100 nits white, 0 black for a standard SDR display. And if there were a profile loaded or we had taken some measurements, then this would be the information from the profile itself. Obviously the options like active LUT, pre-roll, patch scale, so be it video range or data range. We will have bit depth control as well, not yet active, and control of the patch size itself. So here we've got, let's say, an L30 patch size. When I open up the patch window, initially it's a resizable patch window with information on both its position and size and the probe it is connected to, because you can have more than one patch active and more than one probe at any one time. And if we double click it, we will see that we get the L30 size with our black background. I say that we can have more than one probe active at any one time. That's because these windows are all independent. So if we open up a second one, we can actually connect this one to a different probe. At the minute it says the I1 is busy, so we can go and select a different probe, and then we can actually connect to that and open up its own patch window so that we have more than one happening at any one time. More importantly, we can open up an existing colour space so that we can be looking at another colour space while we are manipulating a display via measurement. So here if we look at this profile, we can see all that information, and while at the same time we can actually be taking measurements in this window. Okay, back to our measurements, and we are going to just look at the options we have for setting, for example, patch colour. So we've got the usual sliders to set the patch colour, and if we take any measurement it will populate into the graph. So if we go look at say some black and white to start with, so we can show the min and max being configured. At the moment the lock buttons aren't working, so I'm moving all three independently. But if we just make sure that we've got everything set there, yep, we can take a measurement and it will populate into the graph the black reading. There we go. And then if we go back to white and take that measurement again. Okay, we've now got those two set, and if we go back to settings you can see that we've now got that information in our profile. So rather than trying to match to the set target of 100 nits and 0 black, we can actually populate that with the real display data, which obviously means we're getting a little bit more understanding of what the display can do, irrespective of its actual peak or min luminance values. Now, while I'm setting these sliders manually, there's actually a better way of doing this when you're working with displays that have specific requirements for their patch values. So for example, a display that has a particular requirement for 21-step grayscale or 12-step grayscale. That's by using presets, because we can load in what is a list of colours that is just a CSV list, and it will populate the menu with those exact colours. That means you can define exactly the colours that you need for your display. And if you look, this is the CSV that we've just loaded that has the patch number, the triplet value, and the patch colour name. This is based on memory colours with a grayscale. And if we double click any of these patches, it will add that colour into the profile. So you can see straight away that we're building up profile data point by point. And if we go back to the ones that we did previously, then we can override those values that we've already taken with new updated values. And then if we want to see the entire profile itself, then we can simply select Auto Advance and then repeat with Measure, and it will now step through each of those patches in turn, and you can see that the sliders will actually step forward through each of the patches in turn. It will step through the presets here as well. At the moment it doesn't until the profile is finished, but you can see the actual patch progression by looking at the sliders, and you'll see in a moment as it gets into the colours that it will start bouncing around, but at the same time showing us the information on the CIE chart, including the target tangent lines. We'll just let that run through. Okay, so that's completed the entire sequence, and we now have a populated graph. At the minute it's only showing it in the CIE graph, and we are lacking the ability to save that as a profile just because we haven't got that bit working yet. But it will populate it into the various gamma graphs and so on, because it will become a saved profile just like any other. So if we look at a profile in itself, and we'll go back to the chroma one that we were messing around with earlier, making the, there we go, because this one is just a nicely populated display. And what we're going to do is, first off, we're going to just show it in its raw form, and then we will look at it. Let's just boost that up, there we go. So now we can see the display data, and we are comparing it to the Rec 709 target, which is the white triangle. And you can obviously see the display has a lot more gamut capability than that. Gamut's not too far off. So, first thing we're going to do is to look at it in its own form. So we're going to compare the display to itself effectively. and we will do that simply by selecting the profile luminance to replace the target luminance from the display we were just profiling. And we can see that we now have a better understanding of the luminance errors, but we will also select the color space that we extracted from the display, so we can now see all the information mapped to itself. This gives us a far greater understanding of the inherent capabilities of the display when we're looking at any of the various graphs. And especially in the three-dimensional graphs, because this is where we really can get to see the level of accuracy of a display in real detail. And if we turn on the tangent lines, there we go, you can see that we've got more chromaticity errors, gamut errors in the lowlights, and then we are getting some error in luminance. As we move up, you can see that the tangent lines are actually showing us that the error is almost near vertical, which means it's a luminance error. And if we go look in it, the RGB cube mode, we can see here that we've got this a little scallop in the colour in the lower area, in the kind of black to green axis into cyan, and there's blue, and the blue error is slightly more. We can actually go and look at the display after it's been calibrated, targeting Rec 709 and the actual luminance values that it attained, and we can see now the accuracy of the display against target. If you zoom right into the blue, we can see that's where there is a little error in this display. Let's just turn off the targets for a moment. You can see there that display's not quite hitting the blue. And LUT generation, if we use that same profile, is pretty much the same as in ColourSpace. So we're going to target Rec 709. Again, the gamma has not yet been separated from it, and obviously we're going to use our chroma profile. We will create it just as a peak chroma, and there we have the LUT as generated, and we can see it's a 1D graph showing obviously that the display is excessive blue because the LUT is taking the blue out in the blacks, which is what we would expect, obviously with the white point compensation, and we can see the LUT actually being applied to that. You can see there, that's where the blue is lacking in the display itself. And if we wanted to, we can import an existing LUT. So let's take a film emulation LUT and then look at that in exactly the same way. So here we have a fairly classic film emulation LUT with the standard S-shaped profile, and obviously the fairly standard application of it to, in this instance, the color ramp test image. And again, we can have multiple LUT tool options open, so we can be working on more than one LUT at any given time, exactly the same way as working on profiles and measurements simultaneously. So we can bounce around between all the various capabilities of the system without restriction.